In this video we're going to look at one of the most important concepts in object-oriented programming, and that is polymorphism. So what is polymorphism? In object-oriented programming, polymorphism is basically the ability of a data item, i.e. a variable, a method, so a subroutine or a function, or the object itself to take on multiple forms. And a good example of polymorphism is one where the classes have different functionality while sharing a common set of methods. For example, bike, car and truck may all have different variables or different attributes stored about it, but they can all be driven. Although the underlying code behind the drive method will do different things to the data items within that class. So let's look at an example of polymorphism, and in this example we're going to use two simple classes, one for triangle and one for square. Now these two classes, they're not linked in any way, they don't inherit from a superclass, they're separate classes. But we're going to look at the data items that we'd have to store for each of these classes. So, for the square, we'd have the width and the length. Of course, that would make it rectangle, but we'd have to store the length of the sides. And for the triangle, we would need the length A and also the hypotenuse. Okay, or the height, you can say. And so we're going to store these as data items or parameters inside our class diagrams. And obviously, because it's a square, let's just get rid of width, I think. Let's get rid of the W and just keep it so that every side is sized of length L, because that is a square. So for the methods section, we're going to create a method called showArea. And let's put that into the class diagram. And what I'm going to do now is I'm going to also add a constructor, because constructors are essential when you are creating a class diagram. Every single class should have a constructor. Okay, so now we've done this, we've got our class diagrams completed. Let's take triangle as an example and let's create the code that will allow you to utilize the class in Visual Basic and in Python. So here's the code. On the left we've got Visual Basic, hence the module at the top. Classes need to be placed within modules, but out with the submain. Okay, so a bit like you were creating a separate subroutine, you would just put the class at the same level. So your class definition, class triangle and end class is essential to get a mark. When you're creating your data items, you should probably make these private in an exam as opposed to public. However, for it to work in Visual Basic, you need to make them public, because we don't want to be creating extra methods like set A and set H. It would make our program far too big. So setting them public allows any part of the program outside the class to change those values. Okay, so that's fine as long as we understand that that's why they're public. The constructor, which I'm just going to highlight in red. Okay, the constructor here, sub new, all it does is it sets the value of A to 4, so the size of the base of the triangle to 4, and then the height of the triangle to 5. Okay, as we can see in the class definition, they are integer values. Okay, so we make sure we set them as integers in Visual Basic. And the last part of the code is the method called showArea, highlighted in blue. And what happens here is that it creates the area, or it calculates the area of the triangle based upon the size of the base multiplied by the height and then divided by 2. Okay, and so what it does is it calculates the area, which will be a real number, so we've used double here as our data type, and then we write it out to the screen, and that's showing the area to the user. And so that fulfills our class diagram here. Now to use it, we're going to see how we would use it over the page, but this is how you define it and you set up the constructors and the main methods. For Python, we've got no data types. Remember, Python is untyped, so we're just going to use comments to set up our private data items. Now, it doesn't matter whether we say private or public here, because it's just a comment. So whatever we do will not impact on whether it's private or publicly accessible. The constructor, which is highlighted in red here, okay. Python programmers are going to have a little bit more work than Visual Basic programmers in this one. Again, it just sets self.a, which is the data item here. So self, as in the triangle, itself.a is set to 4, so the size of the base is 4, and then self.h is the height of the triangle to 5. And as with the Visual Basic, the second subroutine calculates the area, okay, and again we have to declare that array, we have to declare the area variable, sorry, as a real number, and then we calculate it by multiplying a by h and dividing it by 2, and then printing it out displays it to the user. So 2 different programming languages used to implement our class diagrams on the left here. Okay, the triangle one. For the square one, it's almost identical, and you're going to see the full code for both Visual Basic and Python on the next page. And here we go. So on our left we've got Visual Basic, and on our right we have Python. As you can see, it's pretty similar to class triangle and class square. We've got one data item, which is L for length. We set that to 4 in the constructor, and then we calculate the area by multiplying length by itself and then writing out the area. Notice that the method in both is called showArea, as in our design. And in Python on the right, again, that's the class triangle from the last page, but class square has got one data item. It sets the length of L to the length of the side of the square to 4, and then it calculates the area by multiplying L by itself, and then displays the output. The important thing to notice here is that their subroutines are the same. Okay, and the same name. This means that we don't care what type of object or what type of shape the object that we're currently looking at is. We can just assume that all the shapes have a method called showArea. And this is polymorphism in action. So we're basically overloading, well, in some situations we may be overloading classes, especially if they've got a superclass, so that one implementation of showArea is different to another implementation. But the benefit of this is that you can program assuming that all of your objects will have the method showArea, and you don't care what they do because that's held within the object.